Hello, we are going to look at example 52, and it says the diagram shows the model of a building with dimensions 19 meters by 10 meters by 12 meters, and the floors are 2 meters high and departs at a position A434. So x is equal to you can kind of see where they draw their little point here. So it's 4 and then 3 and then up 4. So and there you go. And it moves towards the elevator, the path that has the equation x equals 10, y equals 5. So our x equals 10, y equals 5. The elevator moves along the intersection in these two planes, which makes that line that's going to go through the building, right? And that's where the elevator is. How many seconds does it take Anne to reach the elevator if she walks at a speed of 1.5 meters per second? Well, we know Anne's position is point A, right? So Anne's position is point A, which is 4, 3, 4, right? But we know the elevator, right? Its position, its x coordinate is 10, its y coordinate is 5, but its z is what floor is. It's gonna be in the same floor that where Anne is, so that's gonna be 4 as well, right? So if I want to find out how fast she got there, I'm going to find the distance, right? So I'm going to use the distance formula to find the length of segment AE, right? And that would be 10 minus 4 is 6, so that's 6 squared. 5 minus 3 is 2 plus 2 squared, right? And then 4 minus 4 is 0 squared, right? So this is going to be 6 squared is 36, and 2 squared is 4, and that's going to come out to 40. Or you can write this as 2 root 10, right? Good. So that is the distance that she's going to travel. And how fast is she? How fast is she walking? Well, she's walking at 1.5 meters per second. So our time is going to be 2 root 10 divided by how fast we're going. So that's 1.5, right? And that's going to come out to right around 4.22 seconds, right? And there you go. So that's how fast she's going, right? So that's A. B asks us, well, it says Anne takes the elevator down to the ground floor and walks in a direction. Well, her direction is -1, -1, 0, right? Good. So this is the direction she goes down to the ground floor, and she walks in this direction. Given that Annie walks at a speed of 1.6 meters per second, determine the coordinates of the location of the door and the time it takes to get there. State any assumptions you may have made. Well, if we notice, we're on the ground floor, so we know that z is always going to be equal to 0, so we can actually just use the vector -1, -1 as her direction, right? We know her speed is 1.6 meters per second, right? Good. And we also know her position. If she takes the elevator down, right, we know this time her elevator on the ground floor, say, is going to be 10.5, right? So this is the position that she's there, right? So we can come up with a vector equation, right? We know her speed, we know her direction, but first I'm going to have to find the magnitude of this, her direction, right? I need to find the unit vector, right, where this is just going to end up being the square root of 2, right? So when I write her vector equation, it's going to look something like this. R is equal to her position's at 10.5. We're going to have some scalar t, right? And to find out this vector right here, I'd have to take, well, her speed is 1.6, so it's going to be 1.6 over the square root of 2, right, times that direction, right? I need to, I found the unit vector and then scaled it by 1.6, -1, -1. And then when I rationalize this guy right here, I'm going to end up with my vector equation is going to be 10, 5 plus, well, root 2 over, if I go root 2 over root 2, a little crunched in there. Well, this is going to be 2. If we half 1.6, we're going to get 1.8. So, I mean 0.8, my bad. So, and it's going to be a -0.8 root 2, but it's also going to be a -0.8 root 2, right? So this is our vector equation that represents where she's going to be, right? So, and if you look at the graph, she's on the ground floor. She's either going to walk towards x, where x is going to be equal to 0, or she's going to end up somewhere over here, right? It's a little hard to tell exactly from the graph, but we know one or two things are going to happen. Either x is going to be equal to 0, or y equals to 0. So I know that in the situation where x equals 0, right, then I can take the x coordinates, if you wanted to write it out as a parametric equation, you could, but I know that when 10 minus 0.8 root 2 t is going to be equal to 10, right? And so t in this situation is going to be, I'm sorry, I wrote 10. This is going to be equal to 0, right? So I can write this as t is going to be, if I add it this way in the divide, well, it's going to be 10 over a negative 0.8 root 2, right? Which approximately comes out to 8.8, right? 8.8. So roughly like this. But if y equals 0, and then I'm going to have the bottom equation of this guy right here, it's going to be 5 minus 0.8 root 2 t equals 0, and then I'm going to have t is equal to a negative 0.8 root 2, my bad, it's going to be t is equal to 5 over a negative 0.8 root 2, right? And that is going to be approximately 4.4. So we have two possible situations. We got to figure out which one it is, right? And so we know that if we use this bigger number right up here, we're going to expect what happens over here. You can go ahead and check, but if I use the bigger number up here, we're going to end up with something with negative numbers, and that's not going to work. So our answer is the second one that we have right here, this 4.419 seconds is what's going to happen, right? Because we know from the diagram, I mean, we're going to want to know when we get to these doors, nothing should be negatives. And that bigger number, if you go ahead and expect the 8.8 and you plug it into here, you're going to end up with a negative number. And there you go. Thanks, guys.